Back. This is Mr. Hassan's Maths channel. I'm now answering question number 2 from the October 2023 International A-Level Edexcel Statistics S1 paper. So here we're told about the weights to the nearest kilogram of a sample of 33 red kangaroos taken in December are summarized in the stem and leaf diagram below. So this is actually data which is continuous, but because it's been rounded to the nearest kilogram, it's like we have, these discrete values, okay? So it says here, we have the stem and leaf diagram, which has a key, must have a key. A key tells you exactly what each of these represent. So 3/2, 3 represents the stem, 2 represents the leaf. Now it looks like here, it represents 32 kilograms. So before the line, which is the stem, is the tens, and after the line, which is the leaves, the units. So these are the tens and these are the units. So this, for example, this would be here, say 58 kilograms, what that represents, for example. And there's 33 in total, which we should note because sometimes you don't read the question properly and you might miss the fact that there's actually 33. There's 33 kangaroos. Okay, so instead of counting all of these and adding them together, you should know that the total is going to be 33 straight away. All right, so now we're going to use this table. I'm just going to use this copy of it here to save us scrolling up and down every few seconds and giving ourselves headache. Okay, let me just change the color. All right, so we got to find the value of the median. Okay, the median. So we're going to treat this like as discrete data because everything's been rounded to the nearest kilogram, so we can treat it as separate individual numbers. Okay, so the median is the number which is in the middle when you arrange them in order of size. Okay, so these are kind of arranged in order of size, like 16, 23, 26. These are all in order, as we can see. All right, so we got 33 entries. Now, if there's 33 entries, if there's an odd number of entries, there will be one number in the middle value. Okay, now there's lots of different ways that people teach how to identify where the median is. Okay, I personally prefer this particular way because it helps us with the quartiles and makes life a bit easy for us as well. There are lots of different ways that people use, but I stick to this way, which is the way that is kind of explained in the book as well. And so I just want to make life easier for everybody. So this is the way that I do it, although there are alternative methods of doing this. So what I do is I take the number of entries and I divide it by 2, and that tells me where the median is. So in this case, it's going to be 33 divided by 2, which gives you, that's going to be 16.5. Okay, 16.5. If the number comes out as a decimal, you always round up to the next number. So we're looking for the 17th term. The 17th term will be the number right in the middle. Okay, the number right in the middle will be the 17th term. Okay, so we got to count along and find what is the 17th number in this data. So we have 1 plus 2. So if I'm going to put the running total here, you can say the cumulative frequency. 1 plus 2, that's 3. Plus 3, that's 6. Plus 7, that's 13. Plus 8, that's going to be 21. So that's the 13th number here. So we got 14, 15, 16, 17. So this number here, which is 57, so we can say the median Q2, okay, which is Q2 is actually known as the median, is going to be given by the number 57. Don't write 7, it's 57. Okay, we don't forget the stem part. Okay, so that is the median value. And then it says the value of Q1 and Q3. Okay, so Q1 is called the lower quartile. The position of the lower quartile is given by the number of entries divided by 4. Okay, a quarter of the way up. So that's going to equal 33 divided by 4. Now, whatever number comes up here, we have to round up to the next number. Even if it's less than 0.5, we round up. So we have 33 divided by 4, which gives us 8.25. So even though it's like less than 0.5, we always round up to the next term. That's going to be the 9th term. So we're looking for the 9th term. okay, which is going to be, by the time we got to this number, this is the 6th, 7th, 8th, 9th. So this is going to be the value of Q1, which is 45. So we can say Q1 equals 45, and this is known as a lower quartile. And then for the third part of the question, it says Q3. Q3 is the upper quartile. Let me just make a bit more space here. So Q3 is the upper quartile, which is given by 3n over 4. That tells us where it is. Now, 3n over 4 is 3/4 of 33, which is going to be 3 times 8.25. So the 8.25 we got before, we have to just multiply that by 3. That will be then 3/4. That's going to be 24.75, 24.75. So we round up always to the next number, so the 25th term. If the number came out as a whole number, by the way, supposing we divided by 4 or 2 or whatever, and we got a whole number, then we take that term, that position, and the next position. There'll be 2 middle entries or 2 entries in those. We've got to find the average of both of those. Okay, but in this case, it's a decimal, so it comes out as 24.75, round up to the 25th term. We got to identify where the 25th term is. Well, we got up to here, the 21st term. That's 3, 6, 13, 21. We've got to go another 4, that's 22nd, 23rd, that's 21st, 22nd, 23rd, 24th, 25th. It's going to be 63. So we can say Q3 is equal to 63. So we have Q1, Q2, Q3, and Q2. Okay, so those are the values we have for the 3 quartiles. Okay, so that's answer to part A finished. And now we're going to go on to part B. It says, for these data, an outlier is defined as a value that is greater than Q1 plus 1.5 minus Q3 minus Q2. Sorry, Q3 plus 1.5 times Q3 minus Q1, or smaller than Q1 minus 1.5 times Q3 minus Q1. So let's have a look. Let's look at the upper values. We're going to have Q1, which is 45, plus 1.5 times the difference between Q3 and Q1, which is going to be 63 minus 45. Okay, so that's going to be, sorry, Q3. It should be Q3 plus. Upper value is going to be the upper quartile plus the 63 plus that. So it's going to be 60 upper quartile plus 1.5 times the interquartile range. That will give me the upper values for the limits of the outliers. And for the lower values, we're going to take the lower quartile, which is Q1, minus 1.5 times the interquartile range. 1 second. What did I write there? Okay, and that should give us the values for the lower limits. So let's have a look to see what the limits for the outliers are. We have 63 plus 1.5 times 63 minus 45. Yep, that gives us 90. That's for the upper values. And for the lower values, we're going to have, this will be the same. It's just going to be, this is going to be minus. You're going to have 45 minus that. 45 minus this answer. That's going to give you 18. So the lower value is 18. Now, do we have any data values which are less than 18? Yes, we do. Okay, so 8 to 16 is an outlier. This is an outlier, okay? So we have, therefore, we have outlier is 16 is an outlier. Okay, that's for this one. Okay, and for the top one, we have to have anything above 90. The highest is 94. Okay, so therefore we can say 94 is an outlier. Okay, so therefore we can see there are 2 outliers as an answer to show 16 and 94. Okay, so there's the answer to part B of this question. So we've got the value of the median, the upper quartile, the lower quartile, and now we found the outliers. Okay, we found the outliers, and now we can do the following. It says in figure 1 on page 7, so that I put it above here. Okay, shows a box plot for the weights of the same 33 red kangaroos taken in February earlier in the year. Okay, so that's a box plot here. It says, in the space in figure 1, draw a box plot to represent the weights of these red kangaroos in December. Okay, so I need to have 5 key pieces of information. I need to have the lowest value, which is 16. I need to have the lower quartile. I need to have the upper quartile. Let me make some space here. Second, sorry. Okay, so I need to have the low quartile, I need to have the upper quartile, I need to have the median. So let me put it in order. Lowest value, lower quartile. So I'll put it like this: Q1, the lower quartile, Q1, Q2, the median. I need Q3, the upper quartile, and number 5 is the highest value, which we know was 94, I think it was. Okay, so let's go back and have a look at what Q1. So we said Q1 was 45. So 45, 57, 63. 45, 57, 63. 45, 57, and 63. And then you have the highest value, which was 94. Just to confirm, that's right. And lowest was 16. Okay. So we have all the information we need now to draw the box and whisker plot. So I'll do it with the same kind of scale as this in terms of that's going to be 4 wide. But we're going to start off with the lowest value, which is 16, and it is basically outside of our range. So I'm going to put a cross here for 16. And so is 94. That's 95, that's 94. That's an outlier. Okay, our limits went as far as what? Our limits went as far as 90 and 18. 90 and 18. So our limit goes up to 18 on this side, which is going to be here. Okay, so that's going to be our limit for our whisker. And 90 on this side, which is here. That's going to be a limit for the whisker there. Now, we have the lower quartile, which is 45. So that's the lower quartile. Then we have the median, which is 57. That's 55, 56, 57. Okay, that's the median. And then we have the upper quartile, which is 63. That's 65, 63. Okay, and that's what we need. So I'm going to make my box between these values here. So I'll draw my box there. So I want to do like 2 squares above, 2 below from here. Okay. Then I'm going to draw the median, which is a line going in the middle. Okay, that's the median. And then I'm going to join the whiskers between the box and the upper and lower value, which is in the range. And the outliers, I use crosses to draw them. Okay. Now, some people might draw the whiskers to the last value within the limit, and some people would draw it up to the actual limit. What I've done here is I've drawn it to the limit. Okay, I could have also done that by drawing it to the last value within the limit. So I could have, in this case, I could have gone up to 86, and here up to 23. And that would be also the same thing. So I could go up to 86. In fact, that's what I normally do. In fact, that's what I'm going to do now. Okay, 86. All right, so what I've done here is fine. That's perfectly fine. I've gone up to the limit of the outliers, okay, and anything that is an outlier, I've marked with a cross on the outside of it. You'll see that the mark scheme has 2 different options. And a lot of students ask, why are there 2 lines sticking out? They're giving both options. The other option is, as I said, go to the lowest value or the last value within your non-outlier range. So up to here, 26, and up to here, 86. So that's also acceptable. Okay, it's also acceptable to do that. So I could, for example, do this. I could go take this whisker and go up to 86. You go up to 86, which would be there. and that would be fine. Okay, up to 86. Cross. Okay, and that would be fine. And here up to 23. Was it 23? Yep, 23, the last value in the range. Okay, so I could go up to 23 here. Okay, and that would be acceptable. That would be acceptable. Okay, so both of what I just showed you are both acceptable. Up to the last number in the range, which is not an outlier, or up to the limit of outliers, both are fine, and you'll find both answers given. And a lot of students say, "Oh, why I've only got one line sticking out? Why are there two lines sticking out on each side?" They're giving you the two different options. Okay, so there's your answer to part C. So part D, we are told here to compare the distribution of the weights of red kangaroos taken in February with the distribution of the weights of red kangaroos taken in December of the same year. You should interpret your comparisons in the context of the question. Okay, so we should give the answer in context of the question. So we don't just, for example, here we can see very clearly. For example, in February, we can see that the median Q2 was 50. And here we can say the median was, 57 as we found before. Okay. And here we can see that the interquartile range is between this value here, which is, that's 55, that's 58, minus 42, which is like 16. And here we found the interquartile range is between, that's 63, was it 63? 64, sorry, minus, and that's 45. Okay, 64 minus 45, that's about, is it 64? Let's have a look what we found before, sorry. It was 63 minus 45. 63 minus 45. 1, 2, 3, sorry. 63 minus 45, sorry. That's about 18. 63 minus 45, that's going to be 55 to, yes, about 18. Okay, so the interquartile range is slightly bigger here. Okay, it's very similar, but slightly bigger here. But the median is definitely bigger in December. So we can say that we should mention the median value, the median weight in December is greater than in February. Okay, which means we can say that the average weight of the kangaroos increases in December. Okay, and we can also say that the interquartile range, we could say slightly higher, or I think even if we say it's similar, the interquartile range for both is quite similar. Sorry about my bad writing here. So which shows that the variation in the kangaroos' weights doesn't change. The kangaroos' weights changes very little, we can say. Changes very little. Okay, not much change in the variation. So that's how you would write this, or you would interpret this data. Don't just say the median is greater in December and the interquartile range is the same. Talk about it in terms of the weights of the kangaroos. That's all they mean by, interpret the data, okay, in the context of the question. That's basically it. So that concludes question number 2 from the October 2023 Statistics S1 paper from Edexcel International A-Level. Other questions from this particular paper can be found in the playlist that will appear in this section of the screen at the end of the video. Other questions from the topic that we have here, which is to do with box and whisker plots and averages, you can find it in the playlist over here. You can subscribe to the channel by clicking on this link over here, and you can watch the video, which will be linked at the top here, which tells you how to find things from my channel that you might be looking for. Thank you for watching and see you soon.